All right, ladies and gentlemen, what if you know the sides of the triangle and you need to know the acute angle? Let's say there's A, there's B, there's C, and you have your triangle set up. That's 5, that's 12, that's 13. I know this is true. It's what we call a Pythagorean triple. And 5, 12, 13, 3, 4, 5, these are all special right triangles that we can use. So it ends up working. 5 squared plus 12 squared is 169. 25 plus 144 is 169. 13 squared is 169. It works out. Now, what is the measure of angle B? Now, the thing is, we're going to use trig. But not the sine, the cosine, or the tangent. You can't use those because that's always saying if you know the angle, you can use these. But if you know the sides, we want to use something else. Now, I know that the sine of x, or we'll say the sine of b, is going to be equal to the opposite side divided by what? Divided by the hypotenuse. So if I'm dealing with this angle, there's my opposite side. Does anybody disagree that the opposite side is 5? Alright, so the sine of B is 5 divided by, well, what's the hypotenuse? 13. Well, this doesn't help at all. But there's one thing that we can use that we haven't used. Anybody know what those are? We need to know the inverse trig functions. We need to be able to get at the b in here. So we need something that's going to knock out the sine function. And the only thing that we have that we can use is this. It's called the inverse sine, or we see it as sine to the negative 1 power. Although this is not sine to the negative 1 power, that's what it looks like. So we do this. We take inverse sine of the sine of b is equal to the inverse sine of 5/13. Now, the relationship between the inverse sine and the sine is like adding and subtracting. It's like multiplying and dividing. If I added 2 and subtracted 2, did I do anything? Made it 0. I didn't add or subtract anything. If I multiplied by 5, then divided by 5, did I do anything to the original number? So if I have an angle, if I take the sine and then I take the inverse sine, did I really do anything to the angle value? No. These two cancel each other out. So now, sine, or the angle B, whatever the measure of angle B is going to be, it's going to be equal to the inverse sine of, it ends up being opposite over hypotenuse, 5/13. But here's an issue. our calculator is going to screw this up. So I'm going to show this to you. Now, this alone is a button, and then these are just the letters. But together, this tells the calculator to convert from radians to degrees. Now, we don't have to know what and understand exactly what radians are yet. And you're not gonna until we start talking about that. But let's jump to a calculator. And so we know inverse sine of 5 over 13 is equal to angle B. So I'm going to get out of here and I'm going to jump into my calculator. Now, I'm going to show you this, but if you change it, I'm going to be extremely very, very mad. If you go into settings, and this one says general, sometimes it says document settings, and it says angle. If you go in here, there are 3 different choices: radian, degree, or gradient. It needs to stay on radians, because I don't want you going in there and I don't want you changing any of the general settings of the calculators, because that's not anything that you need to worry about. All that does is it screws it up for other people, so I don't want you to do it. But here's what we'll do. Over here, right by the 7 is the trig button. In the top row, this is if we know our angle. We'll use the sine, cosine, or tangent, like the sine of 60 degrees or the sine of 45 degrees, something like that. Here is where we have our inverse sines, inverse cosines, and inverse tangents. And depending on what sides we have, those are whichever one we're going to use. We're going to use inverse sine to start with. So I want the sine of 5 divided by 13. It depends on the sides you have. If you have an adjacent side and a hypotenuse, you're going to use the inverse cosine. Well, you know what angle you're looking for. You should have a picture of the triangle. So whatever angle is, you always base it off the angle you're looking for. Now, to find that triangle that's pointing to the right, there's a button that's 2 to the right of the 9. It's a book. You don't press the book, but you hit Control Book, and it brings up a bunch of different characters. And in the first row, you have pi, e, I, you have this, e, infinity, theta, and arrow. I want that guy. And the neat thing is, once you use it, it always stays there until you use something else. And then you just go to D and hit DD. And what it's going to do is this is saying now, I'm taking the inverse sine of a ratio of sides, and that's going to give me an angle. But I want the angle in degrees. I hope we're not doing anything inappropriate on our calculators. Hit Control Book. You hit the D button twice. There's a keyboard on the bottom. You hit like you're texting someone. That's fine. When you hit Enter, it'll change. Well, what do you mean? Well, your calculators were in degrees. They weren't in radians. So you didn't have to. All your answers would come out in degrees. But I have classes that need these calculators to be in radians. And so the radian, it's always in radian form, and now you just have to worry about changing things to degrees. So if I use the cosine of 12/13, I'll hit Control Book to pull up all those symbols. I'll get my arrow, and then I'll just go to the D button and hit that twice. And it could come up lowercase because mine comes up on my handheld calculator. It comes up lowercase. But when you hit it, your calculator knows what it sees. And you get your angle. The thing is, you got to know what side you're using. You got to know what angle you're using. Now, if we jump back to here and I want to find angle A. Now, angle A, I want tangent. I want to use my tangent of A. So the tangent of A is, if I use the SOHCAHTOA, the tangent is what? Opposite over adjacent. So what's opposite of A? 12. And the adjacent is 5. Now, in order to find A, we just switch it over to this. A is going to be the inverse tangent of 12/5. So then we jump into our calculator and hit trig, find our inverse tangent. 12 divided by 5, if you hit enter, you get this number. Which is if you end up doing this and you use your inverse and you get a really small number or negative numbers or things like that, then you probably didn't, you got your answer in radians. You didn't actually put it in degrees. And you didn't tell your calculator to put it in degrees. So that's where you have to do the triangle DD. That converts it to degrees. Question? No, I just chose it to be because you can use if you know all three sides, you can use any of the three: sine, cosine, or tangent. So what I would do is I would go back here and say, all right, well, I didn't tell the calculator that I want the answer in degrees. And that's what this is doing right here. Triangle DD tells it that we're going to be using this in degrees, and I got 67.3801. Now if I put that 67.3801 plus 22.6199, these two angles, if I add them together, what should I get? Just remember that these two angles together, A and B, should be equal to 90 degrees.
So when we find one, should we just do 90 minus the other? 90
If you're looking for both of them, you might not be looking for both of them. All right, let's take a look at number 2 on the right triangle trig worksheet. You are 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So we got to draw our picture. When we say we're 200 feet from the river, that means that we are right here. Okay, 200 yards. But that means that we're at a straight angle from, or a right angle from there, and the path is straight right to the river. How long is the path? $400 yards. Now it says what is the acute angle between the path and the river's edge? So I want this here. Now, I only know 2 parts of this, right? This is the acute angle that I'm looking for. Is that my opposite or adjacent or hypotenuse? All right, that's the opposite. Now, what is this guy? Yeah, that's your hypotenuse. Whenever you're dealing with the right triangle, you might want to find your hypotenuse first and foremost, just to be done with it. And then you know you're only going to have to deal with the adjacent. Yeah, 200 yards. Yeah, this angle's going to be acute, that angle's going to be acute. But this is the one we want because it said we want the angle between the path and the river. So here's the path, and here's the river. So now I have the opposite side and the hypotenuse of the sine, cosine, or tangent, SOHCAHTOA. Which one do I want to use? Yeah, the sine of x is equal to 200 over 400. So now to find x, I'm going to have to do this. I have to use the inverse sign on both of them. The sine and the inverse sign, they undo each other. I'm left with x. X is the inverse sine of 200 over 400. And remember, I got to do this. Because then the calculator will actually tell me what I need to do. So in the calculator, we'll go here. I need an inverse sine, so I'll get my inverse sine. I need a fraction, so I'll put a fraction in there by hitting Control Divide. 200 divided by 400. Then I'll move over here, and I'll make that. Now I have to tell the calculator I want degrees as my answer, so Control Book, use the triangle, hit DD, and you got 30 degrees. So if we jump back to the picture, I know this is 30 degrees right here. What's this angle then? That'll be your 60 degrees. Now tonight, ladies and gentlemen, on both sets of worksheets, I want you to work on the even problems. There's the next one right up here, Ivan. Put the phone away or else I get it. And I'll send it right to Mr. Lindsay. That's worse than having it taken by the principal, I'm sure.